Well, first of all, thanks for coming, and I hope I won't bore you too much with some of this. What I've done is I've printed a sheet off here, which is a very basic foundation, if you like, to start to set your car up from basically having it on a stand where you've bolted all the wishbones and things on, and you're trying to get it in some form of squareness and ready to be able to put it on the ground and start to do some real measurements. So I've also, that's the first sheet. I've also got just a pretty picture there of some basic places and terms which we would consider to be the standard of what we're talking about, as far as the definitions, such as where you would change the caster of the car. We'll go over what that means later. Where you would measure the ride heights, and I've just gone back pretty much to basics. A lot of it will be fairly common to you all, but there are some new guys here. So there's some descriptions there, and then there's two more sheets here that are what I call terms and definitions of the language which we use when we're talking about the car and how we're setting it up and what we're using to do that with. And then the next sheet back basically runs over those same points, but shows you or tells you where you would adjust and what bits you would look at to perhaps make some changes to that, obviously once you've made the decision to change something. So I think the first part of it is that there's always, and racing drivers are inherently like this, and me being one of them, I was always like it myself, and having run lots of other drivers, there's always this I need to go faster, I need to go faster. Okay, now there's nothing wrong with that, that's the competitive nature of car racing, but there has to be, in my thoughts anyway, there has to be a certain amount of discipline in that you need to have a basic setup which you would use at any circuit. So you need to decide on what that's going to be, and then as you go to the circuits and you find that the car's not doing this or it's not doing that, then you would make some changes, see if it's better, very importantly document what you've changed, and then let the weekend just progress and go, well yeah, actually this is going pretty well. The weekends we're getting a little bit faster and we're more competitive than we've been here before, etc, etc. And then, but you might get to a point during the weekend where you go, well actually this isn't working. So what do you do then? So you've been through the first practice, you've been through the second practice, everything's going good. Go out in the third practice and you go, I'm 7/10 off. What's happened? So what do you reckon? What do you reckon that could be?
The position of the track changes.
Easy thing to blame. Yeah.
Something's gone out of alignment or out of setup again.
Another easy thing to blame. Very, very good point. Yeah. Not a very easy thing to blame, driver. Okay. Also, there's also a perception that if you change something, it's going to be better. Right? And that's something that humans have in their psyche, that if you make a decision that you're going to change something and you change it and you go out and you think it's better, then in your mind you are going to convince yourself that it is. Try not to do that. Try desperately to work off the stopwatch and try and keep all the other parameters that you haven't changed the same, so that you're only changing one or maybe two things at a time. And it's terribly important that you have some form of discipline just in your own mind, that's all, because it's really easy, and we've done it thousands of times with all the different people that we've run over the years, where you start the weekend off and you change this little bit of toe in, and you change that bit of caster, and then you go this way and then you go that way. You get to the end of the weekend and you're a second and a half slower than you were when you got there. And I think we've all perhaps been there before. But the trick is to identify it early and go back to where you started from. And that's the key to using that little bit of discipline and getting back to what you consider your standard setup, where you've been to Timaru 10 times in the last 5 years and you know you can do 7 deads there. So the bit of tarmac doesn't change, probably the engine and the car hasn't changed that much, you should be able to do a 7 dead. And if you had a bit of a tweak around and it's not working, there's probably a reason, and it's more than likely those little tweaks have just wandered away from your standard setup. And I can't emphasise that enough really. So I won't harp on. Does everybody understand what I'm talking about? There's not really many parallels with it because it's such a dynamic thing, but that's the psychology of trying to keep control of the way your car's set up and how it's performing. So we need to have a bit of a think about that. Okay, so this front sheet here goes through the beginnings of what you would do to the car when it's on the stand. So you'd have it on the stand, you'd set the chassis up relatively level, and you'd start by bolting on front wishbones perhaps. You'd bolt those on. You'd have all the rod ends in at the same length out of the wishbones. And the first thing you do is you get your tape measure out and you measure from this bottom point down here back to a common point at the back of the car here. You could use the bell housing here, or you could use the gearbox bung here, which is in the centre of the car. Essentially make a triangle out of it and make those lengths the same. And it doesn't actually matter whether it's 2 metres 10 or 2 metres 5 or whatever, but that's the building block of the setup of the car. So you get that one right to start with. Then you put the top wishbones on, and then you'd put your uprights in, and you'd initially set the camber, which we'll talk about in a minute. You'd initially then set the camber and the caster, and we'll go over those in a minute, by measurement dynamically rather than by just putting a level on. The front wishbones, the top ones in particular, they should still be at an even position from the rear as well. So you've got 4 points all in a triangle, and whether it's got the right amount of caster or the wrong amount doesn't matter at this stage. So you do that to start with. Then you'd go back to the rear of the car. You'd pick the wishbones which are the hardest to adjust. I mean, on a Stealth it's relatively easy either way. On the 91 Van Diemen's and certainly anything with a rocker in it, you would use the fixed points that can't be changed, and you would check to make sure that those diagonals are correct as well. Once that's done, then you can start to look at whether or not you've got the casters and those things correct. We won't go into the rest of the setup down here until we talk about a little bit what's on the other page first, because some of the stuff that I'm talking about is probably going to be a little foreign to you. Skip the pictures for now. Okay, so common terms which we would use, some of them are relatively self-explanatory. Ride height, everybody know what we're talking about? Where's it measured? And how much should it be?
40 millimetres minimum,
yeah.
And underneath anywhere on the bottom of the car under the chassis itself.
Right, okay. So at the lowest point or at the highest point, or?
Whatever minimum at 40 millimetres at any point.
So we're talking about at the skid, which would generally be below the floor tray of the car. Okay, that's fine. Okay, so that would be common to the front and the rear. What about the rake of the car? Everybody know what we're talking about when we're talking about the rake of the car?
How far it's tipped off level.
Yeah, forwards or backwards. Yeah. So where's that measured? Is that measured off the skids, or is it measured off some other datum?
Just whatever datum you choose.
So what would you typically use though? Floor pan. Floor pan. Yeah. So the rake of the car would be taken from a datum that you either know, or if the car's got a flat bottom, you'd use the front or the back. I mean, cars like this, for example, you can't use the front because the chassis is not flat; it kicks up at the front. So a Stealth would be, the front ride height would be done here, and the rear would be done just in front of the skid. But be very careful that you don't measure the skid, because the skid could be 8mm thick at the back and 3mm thick at the front, or vice versa. So the rake is something which is only a number that comes from a datum face. So the floor of the car is the datum, and if it was flat, then it's a number which is common to most cars. Somewhere around the 6 to 8 millimeters would be typical of Spectrum, the 91 Van Diemen, or any cars like that. These particular cars, you can't use 6 or 8 millimeters because you're measuring it here, not there. And so the rake that you would use on a car like this would be about 2/3 of what typically you might use on a flat bottom car. So once again, getting back to something that you know is really important, and be consistent about it. Okay. What about the camber of the car? Camber of the wheels. Does everybody understand what we're talking about? So we're talking about the angle of the tyre to the ground. Why would we change it? Any ideas? So we get the best tyre wear?
You get the most grip going around the corner.
Yep. Would that typically be flat with the car, do you think, or flat with the ground? Or so why would we have the wheels tipped in what we would say tipped in at the top?
It's tyre deflection, so where the tyre is rolling as a result of the sidewall,
Yeah.
and the gravitational forces pushing the car out, rolling the tyre around and trying to increase the size of the surface area to a maximum width to keep the maximum amount of rubber on the road.
Okay. Have you thought about the fact that if that was the chassis, when you go around the corner, the chassis tips over like this? So what does that do to the wheel? The wheel's sitting here, bolted to the car. So as you go around the corner, the chassis rolls over and tries to tip this wheel over like this. And we don't want it in that area, we want it straight up and down or a little bit this way. So the camber is there to compensate for the amount of roll that the car's got. So the stiffer the car is, the less roll it would have. Typically the less camber you would run, depending on some other geometry issues. But typically the reason for the camber is to allow for the inherent roll you're going to get when you go around the corner.
Chassis roll or other factors as well?
Chassis roll mainly, yeah. I mean, what I'm saying is, if that's the chassis and we've got pickup points top and bottom, it's going to move like this when you go to the left. So this point's going out that way, it's going to take the top of the tyre over. Okay. Won't dwell on that too much. What about the next, probably one of the most important parts of the front suspension and the rear to a certain extent, but more to do with something that gets forgotten about a lot, and that's the caster at the front. Everybody understand what that is?
Nope.
Nope? Okay. If you, what happens when you turn the wheel on the car? You turn the car, the wheels are there. Has the car got the same camber on it now than it's got when it's straight? Take a look, doesn't look like it, does it? No. So the caster is a function of the geometry of the front upright and the difference between the position of the top pin and the bottom pin. And what it does is it also allows for that roll. And the harder you turn the car in, the more the car's going to roll, especially if it tips up a little bit at the top, at the back rather. So that means that the more caster you have, the more camber you're going to have as the car turns. And there's a happy balance between the amount of camber that you have and the amount of caster. Does everybody know how to measure the caster?
The angle is leaning back.
Yeah.
The number of degrees from vertical.
From
Lock to lock and measure the camber through the line from the top and the bottom pickup.
Okay, so the important thing there, Derek, is that it's not relative to the ground. It has to be relative to the bottom of the car. And that's where we get back to this datum thing again. If you use it and you were checking it and the car had 8 mils of rake in it, then that's going to change the amount of caster that the car has. So you always check it in relation to the floor of the car or some other common part on the car that either you're using or someone else is giving you the information from. Okay. Now there's two ways of measuring the caster. One's the static way of doing it and the other way is the dynamic way. And what you can do is you can take that nut off there and screw a flat plate on there, and you can put your camber gauge straight on there and measure what angle that upright, or you can put your camber gauge on the top of the upright and measure what it is, and then compare it to a 0 or some datum that you've got on the car. It's not a particularly good way of doing it, it's a quick way of doing it, but it doesn't necessarily tell you the truth all the time because of the variations in the machining of the uprights, especially in some of the older cars, especially the very old cars with the old Triumph Herald uprights. They tend to bend quite easily, so you can get some quite big variations. But the best way, and you'll see on the floor here, now we've got two lines marked on here, and the 2 bits of tape. Now those lines are 20 degrees from the centre either way. So if you turn the wheel 20 degrees that way, generally on a Stealth or a 91 Van Diemen it's pretty much on the stop, and you measure the camber, you might have 3 degrees there, and then you move it 20 degrees the other way, or 40 degrees the other way, and you can see we've got, this is now in positive, so we might have 3 degrees that way and 1 degree positive this way, so we've gone from 3 negative to 1 positive, so the caster would be 4 degrees if you use 20 degrees lock to lock, and that will then tell you what's actually going on, not necessarily what you think's going on.
That doesn't get referenced back to the floor at all, because it picks it up as a result of...
It does reference to the floor because what you do is you then check and make sure that if you've got half a degree in the chassis, then you have to take that half a degree off the number that you're getting.
Because then you can alter the rake, and that has an effect on what that means as well.
Correct,
then.
Correct.
Yeah.
Correct. Only a small amount, but I mean, if you were to lift the back of the car up 15 millimetres, then you might induce a degree into it, so you're effectively taking a degree of caster off the car. Okay. Any questions?
Are there standard settings that...
Very much so for these cars, and I mean they're well tried and true as well, and that information's readily available from us if you're happy to come and take our advice, no problem. Here's a bit of a curly one. Toe in or out, front and rear, where's that referenced from?
From the rear of the gun.
Centre line.
Okay, so how would you measure that normally?
Finding centre point from both ends.
Yeah, and then put some strings on the outside which are in line with the centre of the car. Yeah. What's the most important part of that? That the two strings are parallel. We've all got a bunch of bars like this. Not a lot of use if one's an inch wider than the other one. So once again, I mean they sound like silly things, but I've seen it so many times that you're setting the car up, you might not have any bars and you're just using some axle stands, and it's 2 metres wide here and it's 2 metres 100 at the back. So the two lines are like this and you're trying to set the wheels parallel to it. Well, it's just not going to work with it. So once again, it's about getting back to that standard or that datum. So toe in and toe out, that's reasonably easy. Toe in is termed as the wheels pointing this way, toe out that way. Same front and rear. Anybody know what a typical toe setting for the front of a Formula Ford might be?
2 each side out.
1 at the back, sort of.
Yep. That's 1 millimetre in at the back's good. Generally, car like this, 91 Van Diemen, 2 mils per wheel on the front out would be pretty typical. And you can tune to a certain extent how the car is in the mid corner of by changing that toe a little bit, and you'll find that if you get too aggressive with the toe out, the car will get quite taily, because when you go to turn it in, it will snap in because the wheel's cranking out like this really hard.
And you're talking dry settings at the moment, that changes in the wet as well?
Not so much, but I mean it's so slippery in the wet, it doesn't really matter. I mean, the best thing you do would be put a couple of road car tyres on, but you're not allowed to. We used to actually do that in the old days, when you were allowed to use a road going tyre. We'd run on slicks during the day, during the dry, and we put a set of aquajets on. Some of you are old enough to know what an aquajet is. Fantastic.
Yeah.
Absolutely fantastic. I mean, no racing tyre I've ever used is as good as an aquajet. But you can't use them anymore. Okay, so toe to out, relatively simple, and in a modern world we tend to use millimetres, and it's just the difference from the centre line, from this line, and generally from the rim, not the tyre, because the rim's more accurate than the tyre. And the same with the camber. The camber gauge really needs to be set up so that it's working off the rim and not off the tyre. The other thing just to be careful of is that if you are using the tyre's always got a bulge at the bottom. So just measure it back here a bit more rather than in the centre. Okay. The other thing to be very careful of is when you are doing those setups, none of the camber and caster settings are accurate unless the toe is set correctly, because of the function of the caster. Every time this moves a little bit this way, it will crank it either out or in. So when we get to a little bit more in depth with it, you'll see that you have to pretty much set everything up and then make some small changes, and then sort of go around the car a couple of times and check that nothing's moved when you've made some bigger changes. Okay, bump steer. Everybody know what bump steer is? Nobody's checked it? No one's ever checked their bump steer? Right. Okay, so bump steer is pretty much as it says. When you go over a bump, the wheel steers like this, so it doesn't just go straight up and down. Now that happens in the front and it happens in the rear, and well-designed cars generally don't have very much, and generally are engineered in such a way that they don't have very much at all. Some of the older cars have got terrible amounts of bump steer. Some of them have got 10 millimetres of change as a